We're here at the Aerodynamic Flow Control and Diagnostics Lab. We're a lab group that really focuses on making that connection between fundamental aerodynamic ideas and their application to flight test. And so this involves testing everything from small-scale rotorcraft all the way up to very large-scale turbine-powered unmanned aircraft systems. And within that domain, we touch on everything from the fundamental physics of how air interacts with these vehicles, all the way through how noise is produced, how you perceive that on the ground, and how we can connect that back to the performance of the vehicles. As we design drones, there's a lot of assumptions we make about how we design the rotor blades. And so a lot of time as engineers, we spend essentially checking and validating our assumptions and understanding where the models we have break down, right? What are the limits in terms of what we can predict? And one of the best ways to do that is to put a drone in an environment that pushes all of those limits for us, right? And that environment for us would be not on Earth, but on Mars. Recently, NASA has operated a small rotorcraft, a small drone on Mars. And right now they're in the process of developing the next iteration of this. It'd be much larger, much heavier payload capacity, much greater science capability for the Martian atmosphere. And so to support that, we're working on the design of new rotor blade design techniques and experimental techniques that are going to allow us to predict the performance in the Martian atmosphere. And so in Mars, the mean sea level, the base elevation that would be flown at is about equivalent to 100,000 feet here on Earth. And let me tell you, that's about 3 times higher than Mount Everest. There's no helicopters up there right now. There are very few airplanes that can even do that. Within that environment, the air is, the density is very low, the pressure is very low, the temperature is very low. And so when we spin these rotor blades, they are operating in a very, very different environment than anything that we would see here on Earth. And so this, for us, is the best test case of how well we understand those aerodynamic principles of how the flow is moving around these blades and being able to predict their performance.